Okay, what you see in front of you is something called calorimetry. This is related to one of your labs. You use a calorimeter or a device to determine the heat associated with a physical or chemical change. So on the right side of your screen, this is called a bomb calorimeter. It doesn't make a bomb, it's just sealed. Okay, so the point of the sealing is so that you can trap the energy that's on the inside. So this looks pretty fancy. It's probably what they use in a more high-tech lab. If you look to the left side of your screen, this is what most high schools will use. So this is our calorimeter. It's basically a styrofoam cup with a lid, and there's an opening at the top to trap the temperature. So you will do this lab. You will try to determine the specific heat of two different metals, and your calorimeter will be a styrofoam cup. So really it is to trap the energy, and then you watch the temperature change. Okay? All right. The last part of this chapter, we focus on some environmental issues. So our issue is talking about energy. So there is a lot of energy out there in the environment, and sometimes we're using too much of it, and we're not replacing it. So I'd like to talk about some of those issues. Okay, the first one is petroleum. And you don't have this picture in your notes, but it is on my smartboard. So this is just oil gushing out, right? So petroleum is basically a fuel. But what I want you to understand is that it is a fossil fuel, which means plants and animals die and natural processes turn them into petroleum. The problem is we're using it faster than it can be replaced. We're taking it out of the earth faster than these organisms can decay. Okay, and the term fossil fuel does mean it's a fuel coming from fossils. These were once living organisms. They break down or decompose, and they turn into carbon fuel over time. So it's a thick, dark liquid, and the chemistry behind this is they're made of hydrocarbons, which is basically hydrogen and carbon, which is what composes living organisms. All right, the next one is natural gas, and this is associated with petroleum deposits. The main gas is methane, which is why I have the formula here in blue. It's CH4. And there is some ethane, propane that might sound familiar, like propane tanks from gas stations, and butane, which is lighter fluid. So just one thing I wanted to let you know is that gas by itself does not smell, but there is a smell associated with it in your homes or in our labs because it indicates that there is some leak. So a smell is put into the gas to let us know that it's there or leaking. Okay? So that is a type of fuel. The next fuel, again, you don't have this picture in your notes. This is coal down here in the corner. This is another fossil fuel, okay? But this one is mainly carbon, and this is coming from dead plants that get buried. They're subjected to high pressure because they get just pressed on top of each other, and heat over time turns it into coal. Okay, and why I mention this is that it could possibly be used as a replacement for petroleum. As our petroleum is going down, we still need fuel, so coal is a possibility. The problem is it's expensive, it is dangerous to mine, and it does produce some pollutants when burned, and it could lead to acid rain, so it's not the best replacement, but it is there. Okay, and just a side note, remember that this is carbon, right? And another form of carbon is diamond. So that's interesting to think about all these different forms of this element. All right. Next one. You should have talked about this in biology class. This is the greenhouse effect, and the one chemical you need to be aware of is the CO2. It's carbon dioxide. So as these fuels are used up by our cars, by factories, all the increased technology that we have in this day and age, CO2 is being put out into the environment more than it used to be. And why it's called the greenhouse effect. Let me go to my next page here. Okay, here's a greenhouse, right? We actually have a greenhouse in our school. It's in the 140 hallway. You see the plants in here, right? The point of this house is that the glass allows the heat to enter, right? And it keeps the plants warm, especially in the winter. But the glass also acts as an insulator, keeps the heat in there, and it doesn't let a lot of it out. So that's really good for the plants, but it's not good for our Earth. So if you look on the right-hand side, here's the Earth, right? And you see this upper atmosphere. So as the sun's radiation comes in, we have all of this extra CO2 and other gases, and it's not allowing the radiation to leave. So our planet is increasing in its temperature, and it's because of these increased gases, particularly CO2, that stop the radiation from leaving the atmosphere. Okay, so that is what I said here. Carbon dioxide is produced in excess. It absorbs the heat. The trapped heat leads to the planet heating up, and this is called global warming. And it's always fun to hear people say, well, we have these blizzards and all this snow coming, so there cannot be global warming. Well, actually, a lot of these different weather patterns are caused by global warming. So the planet's temperature is shifting. It affects areas that you wouldn't think. And one area in particular is the polar areas, like the polar bears. A lot of the ice is melting. So these different weather patterns are slowly coming down towards us. So global warming is not just increased heat all the time. It does affect more things than just the temperature. Okay? And just because you're in chem, I mentioned some other gases: water vapor, methane, nitrous oxide, and ozone. Those are other greenhouse gases. Okay? All right. Now the last thing to talk about is one of my favorites. First of all, other types of energy that we'll talk about later. I think you know solar energy is coming from the sun. We'll spend a whole chapter on nuclear energy. Wind energy, if you ever travel down a highway, you might see these thin, like white windmills spinning around, and that is meant to create energy and save particularly some of the farmers money. So they use the wind energy to power their homes and their farms. Okay, the last one I want to talk about, it's called biodiesel. And on this slide, you can see this little link here. If you have a chance, try to search for dirty jobs. There was an episode called Biodiesel Man, and he explains exactly what this is. It's using fuel from vegetable oil. Now, the positive is that there's fewer pollutants, there's no sulfur, which smells really bad. If it spills, it's more biodegradable, which means it won't stay on the earth too long, and it will clean the engine better. The problem is you do need to use the oil within 6 months. And the oil actually in this episode was coming from fast food places. So what else did they do with their oil? I thought this was a pretty smart idea. The man took the oil and cleaned it, processed it, and used it as part of the fuel for his engine. The problem is it has to be a diesel engine, which is not in our cars, but it is in trucks. So the formula is B20, and 20% of it is the oil, and 80% of it is diesel. And in this episode, the man driving this car, his exhaust smelled like fast food. So I thought that was kind of cute. So it is a way of reducing some of the fuel that goes into our trucks. And I thought it was pretty awesome to recycle vegetable oil. So it's a pretty neat thing if you have a chance to watch it.